Okay, we have our topic in differential equation. We have the first order linear differential equation. Now, if the given equation is in the form of this one, dy over dx plus p of xy equals q of x, then this is a linear differential equation. And in solving linear differential equation, we have here our main formula or the main form of this differential equation. We have dOy over dx plus p of xy equals q of x, and also dx over dy plus p of y x equals q of y. Now, if the equation follows this format, then we can make use of this formula. That is under the first order linear differential equation. Now, if the equation follows this format, then we will have this what we call as the integrating factor or represented by IF, integrating factor, which is equivalent to e raised to the exponent of p of x dx. This is for this equation. So if you have noticed this one, this is linear in y. For this equation, notice we have here your y. That is linear in y. So we will be using this equation. However, if your equation follows this format, then we call it as linear in x. We have here your x. For this case, your p of y, your p as a function of y, and q as a function of y. So if this is the case, our integrating factor or IF is equivalent to e raised to the exponent of p of y, whatever the value of p of y here, you have to write here your p of y and then dy. Okay, so again, for this case, your integrating factor equals e raised to the integral of p of x dx. So your p of x here is this one, p of x. So again, this equation is linear in y. We have here your y. And for this case, this is linear in x. If you have noticed here, if we say linear in y, you have here your y, and then you have here your dy. Dy and then y. For this case, you have your dx, and then you have here your x. Okay, so we will have our example for this formula. But before that, don't forget to subscribe my TV channel. We have here Tom TV, and then click subscribe. Okay, so we will have our example for this topic. This is our example. Example 1, 2 times y minus 4x squared dx plus x dy. Now take note, we have here our equation for linear in y, and then we also have here our equation for linear in x. So we have to identify this equation if it follows to this equation. Okay, we will try to make use of this one. So by rearranging this equation, we have, let's say, by the way, if you will use dy over dx, then you have to transfer this one on the other side. Okay, we will just try to solve this one. 2 times y, that is 2y, minus 2 times 4. Okay, I will distribute the x. 2 times y dy. Okay, I will transform first dy over dx later. 2 times y equals 2y minus 2 times 4, that is 8x squared. And then I will transfer dx to as a denominator for your dy. So that is equivalent to plus x dy over dx, which is equivalent to 0. So we will try this dy over dx. So we will be choosing this one if it follows to this equation. So we have, by rearranging this one, okay, so we have to divide both sides by x so that we have 2y over x minus 8x squared divided by x. That becomes 8x. So on this part, we divide both sides by x. So what remains here is dy over dx, which is equivalent to 0. So again, I have here an x, so I have to multiply it by 1 over x to both sides. That becomes 2y over x. When we multiply this 1 to 2y, you have your 2y over x, and then 1 over x times 8x squared. That becomes, you will cancel x, so you have 8x, and then this one will be cancel x, so what remains here is ty over dx, which is equivalent to 1 over x times 0, that is 0. Okay, so I will erase now this one. That is why when we multiply 1 over x to this equation, this is the result. And so by arranging this one, so when we arrange this one, we have dy over dx, and then 2 over x is 1 plus 2 over xy, and then this 8x will be transferred to the other side. That becomes 8x. So if you have noticed here, this is now dy over dx plus p of x. Our p of x is 2 over x, and then y, we have here y. So p of x is, this is a function of x, which is equivalent to q of x. This is 8x. Therefore, this is linear in y. So we have this equation, which is linear in y. So if that is linear in y, we will make use of this integration factor, which is if equals e raised to the exponent of px dx. So we will compute our integrating factor here. We have our integrating factor, okay, we have e raised to the integral of p of x dx. And then we have our e, which is the integral of our p of x. For this case is, this is our p of x, 2 over x as our p of x. So we have 2 over x dx. 2 over x dx, the integral of 2 over x dx is equivalent to 2 ln x. So we have here e raised to 2 ln x, or that is equivalent to ln x squared, e raised to ln x squared. Now this e raised to ln will be cancelled automatically. Our final answer here is x squared. Okay, this is by rules of exponential and logarithmic functions. So automatically, if this is the case, if we have, for example, e raised to ln of 3, that is equivalent to 3. If we have e raised to ln of 4x, then that is equivalent to 4x. So that's the case for this part. Now I will erase this one. Okay, so we will now proceed to our solution. We have here our x squared. Now, going back to this one, I will write again this one. You have here dy over dx plus 2 over y, 2 over x, okay, 2 over x times y, that is equivalent to 8x. This time, we will multiply our integrating factor to this equation. So we have x squared. So that is the next step, x squared times this equation. So when we multiply this one, that is equivalent to, I will write here, x squared. I will write here x squared, okay, dy over dx plus plus x squared times 2 divided by x. You have here 2xy. Okay, so we have 2xy. So this is the result when we multiply x squared times 2 over x. So we have 2x, and then we have here our y, which is also equivalent to the result of x squared times 8x, that is 8x cubed. 8x cubed. Now this one is the result of integration by product. So this integration of product, that is equivalent to x squared y. So remember, if we take the derivative of x squared y, we have here x squared y times the derivative of y with respect to x plus y times the derivative of x squared, which is equivalent to, this one is x squared dy over dx plus y, derivative of x squared equals 2x times y, that is 2xy. So if you have noticed, this is x squared dy over dx plus 2xy. So this is the result of the derivative of a product. That is why we have here x squared y. Okay, so I will erase this one. Now, that is now the result of this part. So, which is equivalent to 8x cubed. This time, we will integrate this part. Integral of 8x cubed dx. So, we will apply integration to this part. So that when we integrate this one, that is equivalent to 8x x raised to 4 over 4, which is equivalent to 8 divided by 4, that is 2x to the fourth, okay, plus c. This is supposed to be our answer for this integral of 8x cubed dx. So again, I will erase this one, and then I will write now my final answer, which is this one, x squared y, which is equivalent to, we have here is 2x to the fourth plus c. This will be our final answer for this problem. We have here another example, example number 2, y dx plus 3x minus xy plus 2 dy is equal to 0. Now, take note in our example number 1, in example number 1, this is linear in y. Linear in y. So, how did we determine that this is linear in y? Now, take note, in linear in y, we have here our equation, right? So, if we have this this is formula, if we have this formula, dy over dx plus p of xy, notice we only have here one y, and then the rest is in terms of x. That is why we have here linear in y. So if you have noticed this one, this is in example 1, we only have one y. That is why we have linear in y. Now, how about this one? If you have noticed, we have here y, we have also here y. So, however, they are not in pair. Unlike x, these are in pairs. We have here 3x minus x, y. So this can be rewrite as x times 3 minus y. So if we write this part in terms of x times 3 minus y, that means we only have one x. We have y dx for this part plus plus 2 dy is equal to 0. So if you have noticed, we only have one x for this problem. Therefore, this one is linear in x. Okay, so for this problem, this is linear in x. So if this is linear in x, so I will erase this one, this example 1, and then we will solve our example 2. Take note, for linear in x equation, we have this formula. So we have this formula for linear in x. Thus, we have to rearrange this one by following this formula. So this is dx over dy. Therefore, we have to divide this dx by dy. So what remains here is y dx over dy. And then we have 3x plus xy plus 2. So I will factor x for this part. You have your x times 3 minus y plus 2, which is equivalent to 0. So I immediately divide dx by dy. So I will transfer dy with dx. So we have here as a result. And then by arranging this one, of course, we only need dx over dy. So we have to divide both sides by y. So we have divide by y, that is dx over dy, dx over dy plus we have x, and then for this case, this is 3 minus y, 3 minus y over y, because we divide both sides by y. So we have here y, and then we have here your x. And then these two will be transferred to the other side. That becomes negative 2. Of course, when you divide by y, so that is y. Okay? This time, we will compute our integrating factor after we rearrange this one in the form of this equation. So we will now find our IF, or the integrating factor. So our IF, we have here integral of P of y dy. So this is in terms of dy. So that our integral of our P of y, this is our P of y. 3 minus y over y, or that is equivalent to 3 over y minus 1. Y divided by y, that is 1. Okay, so we will just focus only for this part. And then this is the y. So that when we integrate this one, the result will be 3 ln y, 3 ln y minus, this is integral of 1 dy, that is y. Okay, so if this is y, then we can rewrite this one as 3, I mean e raised to ln of y raised to 3. And then instead of negative y, we will write here e raised to negative y. So we have this one. Now, for this part, for example, in basic algebra, x, let's say uh, 5 minus 4 can be rewrite as x times 5, x raised to negative 4. Or that is equivalent to x over 5 I mean x raised to 5 divided by x raised to 4, which is equivalent to x for this case. So that x equals 5 minus 4, that is 1. So x equivalent. So this is the case for this e raised to 3 ln y minus y. Okay, so I will erase this one. Now, we have here our e. Now, this part is, the result of this part is we have e raised to ln y cube equals y cube e raised to negative y. This is the result of our integrating factor. Now, so we have already find our integrating factor. So this time, after we find our integrating factor, we will multiply this one to this equation. So we have here y cube, y cube, y cube, e negative y. So that when we multiply this one to dx over dy, that becomes y cube e negative y dx over dy. And then we have this one. This is 3 minus y times y. Okay. So what remains here? We will cancel y cube and then y. So we have 3, okay, plus 3 minus y times y squared e negative y. Okay, so we have this one, y squared e negative y, which is equivalent to, okay, which is equivalent to, we cancel y cube and y. The result here is negative 2, negative 2y squared e negative y. That is now the result. And then next, we will apply integral for this part. Okay, dy. And then the result here, of course, our result here is we have xy cube. Okay, so the result here, so we have, this is our x, and then we have this one. So we will just multiply this one, xy cube e raised to negative y. Okay, by the way, we have here x y y squared. Okay, y squared. Okay, this is now the result. And then that is equivalent to, okay, if you have noticed this one, this is the integral of a, we have here y, and then y squared e raised to negative y. So this is integration by parts. We will apply integration by parts for this particular problem. So I will rewrite negative 2 integral of y squared e negative y dy. So basically, this is integration by parts. Now, integration by parts, that is, I will be using the shortcut y squared, and then we have here our u, we have here our dv, that is e negative y. And then our u, we take the derivative, that is 2y, derivative of 2y, that is 2, derivative of 2 equals 0. And then we integrate this one, that is negative e negative y, and then integration of this one, negative negative, that becomes positive e negative y, and then integral, that is negative e negative y. And then we will combine this one. Okay, plus minus plus, so this is minus, so that the result here is x y cube e negative y, okay, which is equivalent to, so whatever the result here, I will multiply it by negative 2. Okay, y squared times negative e negative y equals y squared negative y squared e negative y for this part. Times negative 2, that becomes positive 2. You have here 2 y squared e negative y. That is the result for this part. Then next, we'll erase. For this part, 2y times negative e negative y. Okay, this part. That is equivalent to negative 2y e negative y. And then this negative 2y times negative 2, that becomes positive 4y e negative y. This is the result of our integration for this part. Okay, and then next, we will proceed to this part. 2 times negative, that becomes negative 2 e negative y, times negative 2, that becomes positive 4 e negative y. And then I will erase this one, plus c. Okay, plus c. Okay, plus c. Now, notice we have here e negative y, negative e negative y, e negative y, e negative y. So we will multiply it by, they are common, so we will multiply it by 1 over e negative y. Or we can multiply it by e positive y. Take note, e positive y to this whole equation. If we multiply e to the positive y, this is the inverse of e negative y. So if we multiply this one, this becomes 0. So what remains here is x y cubed is equivalent to, we will cancel this one. So we have 2 y squared, and then cancel this one, plus 4y. 4y. And then cancel this one, plus 4. And then c plus c e raised to y. This will be our final answer.